Welcome to the last lesson in this whole book. I was super ecstatic the first time I taught this lesson. And I'm going to be ecstatic again, but it's a little bit harder because I deleted that before I got to get it all together and edit it and put it on YouTube. So this is my second time to teach this lesson. But it's exciting because it's the last lesson in a book. And when you've finished the book, that's such a big sense of accomplishment. Yes. Once you finish this lesson, you can hold that book and say, I did this whole book. I am awesome. Yes, you should feel that way. You have earned that feeling. And so feel it away. But not yet, because first you got to do the lesson. Then you can feel it. This lesson is almost predominantly review. There's just this one little part on this page in the middle that you haven't exactly done. You've done bits of this, but not in this format. So it's the only part that you might not already know how to do. The rest, I'll just give you a little bit of reminders to show you how to do it, but it's all review because it's the end of the book. You're not going to teach anything new. Anyhow, so let's start with the first section. We will do number 6 together. The directions say to cross off the opposites. Now, because that's the goal of this, you're going to have a lot more opposites than you would typically have, but this is something that you want to use in other long expressions where you've got integers like this. And you'll probably not find as many. You might find 1 or 2, but you should always look for them because by getting rid of the opposites, you make the whole thing a lot easier. So this is a skill not just for this right here, but once you learn it, then you can use it on other assignments when you see opposites. So just make sure that you don't just do this here and then forget about it. This will help you in a lot of other times. Anyhow, number 6. When I look at number 6, I can see this. These are opposites, 6 and negative 6. I've got negative 9 and 9. And I'm left with 94 plus 3. Well, I can do that in my head. 97. Some of these, by the time you cross out all the opposites, you have 1 integer left. So there's not even any math involved. So, you're going to be some easy ones on here. This should be pretty quick for you, actually. Let's skip down to the bottom. I want to do this really fast. I like this because there's a lot of space, and I want to make sure I explain something to you. When the number you're multiplying or you're distributing is on the right side, you do exactly the same as if it were on the left side. And I've had students who know that, but just seeing it this way still kind of trips them up, and it still kind of confuses them, even though they know that it's the same. So my suggestion to you is to rewrite it so that the 3 is on the other side. And I'll show you what I mean by that. And you can do that whenever, anytime you're doing this. Years from now, when you encounter problems like these, if you feel like, I know what I'm supposed to do, but I think I'm going to make mistakes, then just switch it, rewrite it so that it works for you, and it won't change the problem. So my example is this. I'm going to take this 3 and I'm going to put it on the other side. This is how I'm used to seeing it. This is how I'm used to doing it. So I'm less likely to mess up because it just feels wrong. So this is exactly the same problem. 3 times 3x squared, 9x squared. 3 times negative 6x is negative 18x. 3 times negative 2 is negative 6. And when you finish these, you're going to want to put them in the correct order. And you see that it's already in the correct order. When you have exponents with the same variable, you do the biggest exponents first, down to no exponents, and always, always, always the constant is last. Now let's do the middle part. The middle part is the part that's new, you've multiplied variables before. So it's not like you haven't done this, but you haven't done it in the context of distributive property. So that's why I want to do 4 of these with you. Number 1 is, it's the same as the one we did together where the y is on the opposite side. I'm not going to move it this time. There's not much space. You can rewrite it and move it if you want, but for the sake of being able to write neatly in this video and for you to be able to read what I write, I'm going to go ahead and just do it this way. So y times 3y ends up being 3y squared because I've got 2 y's now. Y times positive 5 is positive 5y. Number 3, you've got an x and a y. So xy times 3x is 3. You've got 2 x's, so that's x squared y plus 4xy times 4y. So we get 4x, and then you've got 2 y's, so it's y squared. There you go. If you aren't sure and you think that these are like terms, let me explain to you why they're not. Because even though they both have xy, this is x squared and this one has y squared. So I can't add these together because they're not the same terms. So this is in simplest form. Number 4, look, they gave us some help, the arrows, in case you forgot, in case I forgot. I do forget sometimes. 4 times 2y squared, so this already has an exponent. So when we multiply, I said 4, y times 2x squared. This already has an exponent. So when we multiply them together, we end up with 3 y's. So it becomes 2y to the third plus y times 3x squared becomes 3xy. Then we have y times negative 4 is negative 4y. And finally, number 6, xy again. This time you've got 3 different terms that you're distributing, whereas on this one there was just 2 terms. All right, so xy times 2y squared, wow, so that would be 2. We've got 1x, and we've got y squared and another y, so that's y to the third. Then we've got xy times positive 3x, so that's positive 3. You have 2 x's, so x squared, and 1y. Plus, oops, well, I'll just leave the plus. Negative 4 times xy would be negative 4xy. I don't usually like to write them that way. It's actually, I'm going to change it to my standard. It's better to have fewer signs. Just put minus 4xy. That's the preferred way to put that. And again, I can't combine any of these terms, so it's in simplest form. So that is page 19. On to page 20. We start off finding the perimeter in algebraic form where we don't exactly know what the links are. And so we will use algebra. Finding the perimeter is as simple as adding up each side. So the perimeter of A is simply x plus 2 plus 3x, I like to put that's one side, plus x plus 2 plus 3x. There's no point, you don't have, since this is all addition anyway, you don't have to put those in parentheses. I kind of like to just because it shows that that's one side. Anyhow, so now I'll go through and I'll add up all my x's. 1 plus 3 is 4. This one is 5. This is 8. So I get perimeter equals 8x. Then I have 2 plus 2 plus 4. There you go. See? And then number 2 is the same. Just add up all the sides. Down to number 3. This is very, very simple. You are putting these in exponent form, and they're all the same format. But I want you to see all the different ways that this same format works. I have exactly the same term 1, 2, 3, 4 times. So I will write that exact term one time and put the exponent 4 after it. That's all you do. It works with when you have only one term in the parentheses. It also works when you have 2 terms. So x plus 4, both of these are identical, so I square it, and that's it. There's your page 20. Told you it was review. On to the last page, which again is review. The only one I'm going to go on over with the top is 5x squared, because there is a common mistake I see, and I want to make sure that I address that one. Funny, I highlighted the 5. I was supposed to highlight the 6. Okay, so 5x squared. We're substituting 4 for x, so it becomes 4 squared. Now here is where a lot of people will make mistakes. There's a tendency to multiply 5 and 4 first. But remember, according to order of operations, when you have a multiplication and exponents, you do exponents first. And this 2, it's only squaring this x right here. So it's only squaring the value for x, which is 4. So we're going to square the 4 first. So we bring down that 5, and we write the square of that, which is 16. So we end up with 5 times 16. Let me come down here and multiply it out. I get 80. Back here, 80. There we go. By this point, I feel like you all are really good at this. So I don't think that you'll have any issues with any of the others. Number 7 is like number 6. So when you do that one, think about what I told you. Down here, I'm only going to do number 20 with you, and it has to do with something that we talked about on another page. You might be tempted to just add up all these terms together because they all have x and y and they have something squared. However, since some of them have the x squared and some of them have the y squared, these are not like terms. These are different. So we're going to go through and write and add up all of the x squared y terms. And after that, we'll add up all the x, y squared terms. So let's start with 6x squared y minus 4x squared y. It's a little challenging. I was going to circle that one. X squared. Okay. All right, so 6 minus 4 is 2. Plus 1 is 3. So that gives us 3x squared y. And then we have plus 3xy squared minus 3xy squared. Well, they're opposites, and we can just do that. So we're done. That's 20. So when you finish all of these pages, 19, 20, and 21, I think you should celebrate because you have earned it. This has been a challenging book, but you all have done it. Go you!